Endres is going to introduce today's speaker, Meredith Endres.
Thank you. All right. Good afternoon, Rotarians.
Good afternoon, Dad.
Our special guest up here is Marianne Cairo, who is solely responsible for Meredith's very radiant smile, 4 years in the making, and her new home in Cape Cod. So, yes. Well, many of you know my daughters Kendall and Meredith, and they are very competitive with each other. They've been this their whole life, starting with tennis, whether they compete in Irish dancing or target archery. They compete to see who's the best musician, who's the best singer, and often every summer the big competition is who catches the first fish. Well, the big competition, the winner is who can hold their breath underwater the longest at 1 o'clock in the morning in 2 feet of snow. Well, you get the idea. They're competitive, but the real prize in recent years has been the cup. Yes, who can earn the Rotary Jefferson Cup at the youngest age? They saw their cousin Jordan in 2005 set the record here at Rotary at the age of 15 years and 7 months. And then Kendall got her cup from President Tom Roberts and set the record at 15 years and 5 months. So a year later, Meredith was scheduled to speak at the age of 15 years and 3 months. But alas, a number of school conflicts forced her to miss that chance to set a new record. And I don't know where she spends that time, Twitter, Instabook maybe, I don't know. Meredith is a junior in the STEM program at Edison High School, where she currently serves as the president of the Latin Honor Society, president of Rotary's Interact Club. She's head of the Edison Theater Makeup Department and has been an actor in a number of Edison and Little Theater of Alexandria productions. She's a STEM ambassador and also a member of the National Honor Society and an International Baccalaureate diploma candidate. Meredith has received the coveted Edison Spirit of the Theater Award, and Principal Pamela Brumfield recently awarded her the top Edison Eagle Award. So now, at the ripe old age of 16, she will not be the youngest speaker here at Rotary. But if she does a decent job today, President Sharon may well give her the cup. Her topic today is a major innovation in the STEM education, and it's happening right here at Edison High School. May I introduce to you my little girl, Meredith Endres.
Thank you, Dad. Thank you, President Sharon. Good afternoon, Rotarians.
Good afternoon, Meredith.
All right, we're going to start off today with a pop quiz. Now, I'm going to ask you a couple questions here. What does the mitochondria do in a cell? Anybody?
Breaks up. It stores energy.
Yes, okay. Anybody else? It's the powerhouse of the cell, right? So everyone learns. Now, finish this up for me. Force is equal to mass times velocity. Acceleration. All right, and then last question. Let's switch over to math. Give me the next 4 digits. Pi is equal to 3.14. 1592. Okay. So, but these are facts that everyone should learn in high school, right? And high school science education, it's been taught largely the same way for many generations. The content is taught via textbook, the facts are memorized, and the test is given. However, you might be surprised to learn that a high school has been doing it differently, just 6.1 miles away from here. They happen to be the Youth Interact Club you happen to be sponsoring. Thanks for that. Now, they're piloting this completely new way It's a new approach to teaching science, technology, engineering, and math, or STEM education. This teaching approach pits students against some of the world's greatest problems, using problem-solving techniques to train the next generation. Today, I'm going to tell you about the unique Thomas A. Edison Global STEM Challenges program. In 2008, the National Academy of Engineering compiled some of the world's greatest problems to be solved by humankind. They're the 14 grand challenges of engineering for the 21st century. They are to provide access to clean water, to personalize education, to make solar energy economical, to reverse engineer the brain, enhance virtual reality, prevent nuclear terror, secure cyberspace, advance health informatics, manage the nitrogen cycle, provide energy from fusion, restore and improve urban infrastructure, engineer better medicines, develop carbon sequestration methods, and to engineer the tools for scientific discovery. You may recognize that one of them is to provide access to clean water. This is one of Rotary International's top 3 initiatives, and something that this club has dedicated much time and resources to great effect. At my high school, we are piloting a program that gives students the opportunity to solve these problems as a way of learning STEM. Edison High School created this program 4 years ago with funding from the High School Innovations and Planning Grant from the Virginia Department of Education. It integrates all the STEM subjects: science, math, computer science, engineering, and technical education into one project-based learning environment. I don't attend a physics class, a calculus class, and an engineering class. I just attend STEM as a whole. This program has already gained attention in the engineering and educational community. When the first round of students graduated the program last year, WTOP reported on it.
The first group of students who volunteered to pioneer the Global STEM Challenges program at Edison High School in Alexandria are finishing their junior year without having taken any typical math or science course. Pamela Brumfield, Edison's principal, says instead they've learned all that material together as needed while focusing on world-changing goals.
It's not in silos any longer. Kids bring it together to come up with a solution or to produce a product. It's pretty phenomenal.
Brumfield says the students are motivated by taking on real issues like providing people with access to clean water. While she admits some parents were initially apprehensive about the program,
Children are not missing out on anything, but actually goes above and beyond. What we found was that the learning was actually authentic. This program doesn't teach to a test.
nevertheless, Brumfield says 100% of those in the program passed all Virginia Standards of Learning subject tests. With the National Academy of Engineering, Randy Atkins, WTOP News.
They keep talking about these projects, but what do these projects look like? Well, during my freshman year, as a way of learning biology, physics, and geometry, we had to create portable microscopes that could be taken into the field to find parasites on crops. During the project, we learned biology, such as animal life cycles, and geometry, such as angles of reflection and incidence. Later in the year, in our school courtyard, we built greenhouses that could support crop growth under different harsh climates, applying concepts of photosynthesis and circle geometry, as well as learning how to use design software. As you can tell, this program seems a lot better than learning from a textbook. No? Now I know what you're all worried about. Are these students dedicated? Well, the night before my design brief was due, I broke my foot. So I sat in the ER and finished my design brief, and we got an A. Thank you very much. So today I'll give you an example of what we do using the Design It Clean project we did in my sophomore year. This program utilized chemistry, biology, algebra 2, engineering, and geometry. Now each of our projects starts with a problem to be solved. This problem was to create a filtration device. We were given a case study that takes place in 1994 in Stellarton, Nova Scotia, Canada. People were getting sick from the well water. It seemed to get worse in the summer. The Canadian government brought in water test kits, but they all came back negative. Meanwhile, the number of people getting sick was almost doubling every year. To solve this dilemma, we were taught to use the Knowles engineering design process. The process starts with what we learned is called divergent and convergent thinking. So with divergent thinking, we considered every possible explanation for what could have happened to this town's drinking water. And then as we refined our thinking and applied analysis, we narrowed down the possibilities, or converged to what we believed to be the solution. With this structure of problem solving in place, we could move on to going through the engineering design steps. The first one being problem statement interpretation, asking questions like who's getting sick? Why are they getting sick? Then moving on to design exploration. What are the possible ways that we can solve this issue? Then design optimization. How can we make this design better? And then finally, design communication. How can we communicate this solution to the population? This process allows for students to learn and be tested efficiently while still retaining the knowledge and skills. The first 3 steps are a place for learning and exploration. Then design communication is where testing can happen through techniques such as design briefs and presentations. And not only is this curriculum project-based, but it's also group-based. We learn together, we have our failures together, we collaborate on everything we do, big and small decisions. But there's also the individual work. We do some on our own, but then we always come together and talk about it as a whole. So for this project, my group decided to make filtration tools for individual households. The project seemed overwhelming, so we broke it down into 5 steps. First, to identify the contaminants. Then, to evaluate whether the contaminant can be removed or it had to be prevented. And then research what rids the water of the contaminants, and then create the solution. So step 1, what are the contaminants? To identify the contaminants, we had to analyze the symptoms and cross-check that with the location. The symptoms were a general GI bug that seemed to grow worse every year, and discoloration of the water. The case mentioned that it was worse in the summer. Because most of the wells are open, it's a good chance that algae contributes to the problem. There has to be something else. A general GI bug, it can be caused by anything, from E. coli to cryptobiosis, so it isn't much help. The key phrase is that it is growing in intensity. This implies that the contaminant is accumulating in the water over time, and the discoloration of the water implies a particulate, so not necessarily something on the molecular level. The fact that this wasn't a problem before, and now contaminants are seeping in, might be due to a geographical change, like an industrial development or plant. In biology, we learned that the ground acts as a natural filter, keeping contaminants from the earth and or air out of the water. The fact that this is seeping through means the ground is super saturated with this contaminant. It takes a while for that to happen. So we are looking for a major change that affected the ground and or air that happened in or close to Nova Scotia at least 2 years before the first report. So we can move on to step 2. What are the contaminants? After researching events of our criteria, we learned of the 1992 coal mine explosion. Understand, coal mining is the primary industry of Nova Scotia. And roughly 3 years before the first reports, the West Drain mine, which is one of the biggest, exploded, killing 26 miners. The explosion spread coal particulates for miles, both above and below ground. And having coal in your water leads to discoloration and GI sickness. The mine was quite close to Stellarton, and since there are no other events that could have altered the ground composition in our time frame, we came to the assertion that coal particulates was another one of our contaminants. Now, we use many resources for these projects, in and out of the classroom. Northern Virginia is surrounded with many places for learning. For this project, we took a trip out on a research vessel onto the Potomac and Occoquan rivers. Our guides gave us the tools to perform the testing they normally do. While on board, we used the word turbidity a lot to sound cool. Doing these testing again showed us how these seemingly random equations and procedures applied to real life. We learned to test the water for toxins, get clarity, nitrates, and nitrites. We also collected fish to see how they were doing, and if they were healthy. Just checking up on them. Here's me with my new best friend. The knowledge we accumulated from the classroom and field trips helped us to better understand how to analyze the contaminants for our Nova Scotia project. So on to step 3 then. Can the contamination be prevented or must it be removed? So we have 2 identified. As for the algae, it can be prevented by converting to closed wells. Put lids on them. Covering the well will also protect it from any airborne pollutants. The coal, however, is seeping in from the ground. It's got to be filtered out. So what rids water of these particulates? We found that coal pollution has 3 forms: pieces, fine dust, and microscopic particles. We found the pieces can be removed by 3 layers of cheesecloth, and the fine dust can be removed by a microfiber we substituted for a coffee filter. And the particles can be removed by activated charcoal. We learned about filtration, diffusion, and calculating flow rates. So in step 5, the solution. Our group wanted a household solution that could be portable, cheap, and effective. To make it cheap, we used inexpensive materials that could be found anywhere. PVC pipe, cheesecloth, activated charcoal, pebbles, and the only hard thing to get, microfiber. We used PVC pipe connectors instead of screws so it would be easily assembled. But when we first thought of a filter, we all thought of layers. So we went with that and made stacked capsules. Each one is filled with a different material. This one right over here is filled with activated charcoal and segmented off with cheesecloth. We calculated the volume, how that affects the filtration rate, and as you can see, as the height being 10 inches, we achieved our goal of being portable. Now for all of our projects, there's no set outcome. There's no materials list or procedures to follow. Crazy, right? There's infinite directions you can take each problem. Therefore, the 13 teams took many different approaches to solve the issue. For example, my friend Darius's group, they were tasked to work on a contaminated river in Ghana. They developed a filtration cart that by the time the people had gotten back from the river, the water was completely ready to be consumed. Just like how there are multiple answers, the teachers also stress that everything you do must have good reasoning. We don't get graded on if it works or not. We get graded on if we can explain the process of why it worked or didn't work. Now, this method is very different from the traditional way STEM is taught. And as WTOP reported, many parents were initially skeptical about these experimental teaching methods. However, those worries were put to rest when the standardized testing scores came back. And though learning in different styles and out of order, all Edison STEM students passed the Virginia Standards of Learning tests. The key difference being that we actually know the why behind all formulas and how to apply them, or at least most, in real life. And as you know, these topics are very important to my generation. We know we're not going to go work in a factory for the next 30 years. We're entering a workforce that requires critical thinking and collaboration to address these challenges. That's what makes Edison's program revolutionary and necessary. This program attracts a different crowd. We're not your average nerds. Well, except for 17 of us. And as you know, I've been a guest here at Rotary for many years as a homeschooler. My family, after discussing it for a long time, chose to switch to Edison because of the Global STEM Challenges program, and we've not regretted that choice. Now, during my high school tenure, we may not be able to solve all 14 grand challenges of engineering for the 21st century. That's a lot of work, and I have got to have a social life. But I can promise you that before I graduate, we will solve 12 of them. With your indulgence, I'd like to introduce you to the brains and educators behind the innovative approach to learning science, technology, engineering, and math. Please bear in mind, I may well be graded on how loudly you cheer. So first and foremost is Dr. Katie Sherry, who's the Knowles Academy Program Officer. Dr. Sherry's written much, if not most, of our curriculum. Please stand. Our next special guest is the supervisor of the Edison Academy, which includes our STEM program, Dr. Whitney Ketledge. Please stand. And finally, someone who's succeeding at the hardest job known to man, teaching me calculus, Mr. Percy Canales. After afterwards, they'd be happy to talk to you about some of the new innovative education methods going on and how my high school education is breaking decades-old molds and perhaps setting a standard for all future STEM education. Colleges may still care exclusively about grades and passing tests, and we're doing quite well in that department. But I'm told that employers care far more about students who can apply their knowledge, think critically, and most importantly, produce results. At least, I sure hope that's true. Now, I'm happy to answer questions. One request, please. Try not to embarrass me in front of these people. Okay, listen, they got the power to squash my future like a grape. Okay, thank you very much.